Okay, so we've looked at solving for the angle given the ratio. These ones are similar, except you're going to have some quadratic equations that you're going to have to factor. So let me turn this on. So it's up to you whether you want to just use the equation as is. So here we have sine squared theta minus sine theta equals 0. So some students like to replace the sine with another letter, another variable. So if I said that sine theta was equal to m, then sine squared theta would become m squared, and sine theta would become m. So now I want to factor. So if we think about our factoring process, the first thing I generally look for is a common factor, and I see that both of these terms have a common m, so I'm going to factor that out so that it's in factored form, and then I'll take each factor, set it equal to 0, and solve for m. And then you have to remember to put that sine theta back, okay? Don't leave it as m equals 1 and then try to solve from there, because it's not the same thing, okay? Because we're dealing with trigonometry. So I'm going to replace the m back with sine theta. So there's one factor, and then I'm going to put the sine theta back here, and there's my second factor. So now I have to find the value of theta when sine theta is 0 and when sine theta is 1. So normally we would say, okay, can I use my special triangles to do this? We can't. My second option would be the graph. So this is a good option for this question because I can just sketch the sine curve. I want it over the interval 0 to 2 pi. So I'll just sketch it from 0 to 2 pi. So first I'm looking at theta when sine is 0. So here, here, and here. So at 0, pi, and 2 pi. So that starts off my solution set. So 0, pi, and 2 pi for when sine theta equals 0. And then where does sine theta equal 1? Here, which is at pi over 2. So that's my solution for that factor. And then that's my solution set. You don't have to change it to a different variable if you don't want to. I generally don't. Doesn't really bother me to factor it. Oops. Common factor. Doesn't really, change much if I just take out a common sine theta and then solve it that way. If you like, sometimes visually, students like to have it look familiar to the factoring that they normally do, so that's why they like to replace it. But it's not necessary. It's up to you. Right, so if I did it this way, then I would just say sine theta equals 0 and sine theta equals 1. So I'm sort of skipping that step of replacing it. Okay, so let's look at this second one. This is another common factor question. It's a quadratic. My first option is common factoring. So we can replace with a letter if you want. So we'll use m again. So 2 sine squared theta would become 2m squared. And then sine theta is just m. There is a common factor of m, so we'll take that out. And then set each factor to 0. So m equals 0 and 2m plus 1 equals 0. So solving for m, we get -1/2. And then we need to put the sine theta back. Okay, so don't forget to put the sine theta back. So sine theta equals 0, and sine theta equals -1/2. Okay, so those are my two factors. Now I have to solve for both of those. So sine theta equals 0, that is going to be found on the graph. Right, so where is it at 0? At 0, pi, and 2 pi. So that goes in the solution set. And then sine theta equals negative 1/2. Well, that is the other process where I'm going to use my cast rule to determine which quadrant it could be in. So it's a negative ratio. So it could be in quadrants 3 or 4. So I'll draw those. Sine is opposite over hypotenuse, so negative 1 goes there. And then I have to figure out the related angle. So if this is negative 1, this side is root 3. So that makes my related angle pi over 6. Okay, so pi over 6 is always next to the root 3. And so my solution for this one is from 0. So here we have pi plus pi over 6. So that's 7 pi over 6. And then here we have 2 pi minus pi over 6, so 11 pi over 6. So sometimes you might have to use a combination of special triangles and also the graph, depending on what your factors are. Okay, so whatever process you need to solve for that factor, that's what you're going to use. Okay, so here's another one. Cos squared plus 3 cos plus 2. I'm going to let cosine theta be replaced by an m. So cos squared theta would be m squared. 3 cos theta would be 3m and 2. So particularly with this one, it kind of makes it more visually appealing to put it as a quadratic that you're familiar with. So you know how to factor m squared plus 3m plus 2. It's just a simple trinomial. So we need two numbers that multiply to get 2 and add to get 3. So it'd be 2 and 1. And then we're going to set each one to 0 and solve for m. And then we're going to put the cosine back. That's a negative. Okay, so let's have a look at these two. Okay, cosine theta equals negative 1. I'm going to draw the graph over the interval 0 to 2 pi. And I can see that it equals negative 1 here, which would be at pi. Okay, so that starts my solution set with that one. Now, cosine theta equals negative 2. Well, that is not on a special triangle because it would be 2 over 1, and I don't have a special triangle that has a hypotenuse of 1, right? We have 1, 1, root 2 for the pi over 4, and we have root 3, 1, and 2 for the pi over 6 and pi over 3. So I don't see any cosine there that is 2 over 1. If you typed cosine negative 1 into your calculator, it will say error. So why is that? Well, if you think of the graph is really created by the ratios. So it's not, well, we know that the graph when it goes up to 1 and down to negative 1, the standard graph. So it never goes below negative 1 unless you stretch it. But the graph is created from the ratios. So what is a cosine ratio? I'll draw it over here. So a cosine ratio is representing the adjacent side over the hypotenuse. And what do we know about the hypotenuse? If I draw a right angle triangle, I know the hypotenuse is always the longest side, right? We know that from the beginning. That in a right angle triangle, the hypotenuse is always longer than the other two sides. So if you have a ratio where the number on the denominator on the bottom has to be longer or a bigger value than the number on the top, that ratio will never be bigger than 1, right? It's just not possible. So I could have 1 over 1. That gives me 1, right? So that's why the maximum is 1, because if the adjacent side is 1 and the hypotenuse is 1, then cosine is 1. But that number on top will never be bigger than the number on the bottom, so that number will never get over 1. Okay? So cosine theta and sine theta, because it's also true for sine theta, because think of sine is opposite over hypotenuse. They are never greater than 1 unless they are transformed. But if we're just talking about regular sine and cosine without any transformations, they are never greater than 1. So if you get a root that is more than 1 or less than -1, it is an invalid root. So cosine theta equals -2 is invalid. Okay, so you need to indicate that so that I know that you know that it's invalid. So my solution set is just pi. So the only valid root is cosine theta equals -1. Cosine theta equals -2 is an invalid root and therefore doesn't have a solution. Okay, so that's one thing that you need to be careful for and watching for when you're solving. Okay, this one I'm going to change cosine theta to an m. So 2 cos squared would be 2m squared, 3m plus 1. This is a harder trinomial, so whatever method you use to factor is up to you. You can use decomposition, you can use trial and error, you can use crossover. I know that 2m squared has to be 2m times m, that's my only option. And I know 1 has to be 1 times 1, that's my only option. And then added together gives me 3. So it's not a hard one to factor. So let's take each factor equal to 0 and solve for m. And then we're going to put the cosine theta back. So there's one root. There's my second root. And then we're going to solve. Okay, well, the -1's easy. I'm just going to draw my graph. Find where it equals -1, which is here, which occurs at pi. And then my cosine theta equals -1/2. We're going to use the cast rule. Cosine is negative in quadrant 2 and 3. So we'll draw a diagram in 2, a diagram in 3. Cosine is adjacent over hypotenuse, so the adjacent side is -1. The hypotenuse is 2, so that creates a related angle of pi over 3. Okay, so I'm ready to do my solution set. So theta equals to here, so this is pi over 3. So in quadrant 2, it would be pi minus pi over 3, so 2 pi over 3. In quadrant 4, it would be pi plus pi over 3, so 4 pi over 3. And then on the graph where cosine theta equals -1, it's equal to pi. So I have 2 solutions for the first root, and I have 1 solution for the second root. Okay? I don't mind what order you put them in the solution set. If you want to put them in numerical order, that's fine. If you want to just write them down as you complete them, that's fine too. Okay. For this one, we have a sine theta and a cos squared theta. Well, I can't factor that or solve that like it is because I can't have 2 different variables. If you have 2 unknowns or 2 different variables, then you can't solve it with 1 equation. We have to have 1 variable, right? So I'm going to go back to 3u, and we had our Pythagorean theorem trig identities. So remember that one of the trig identities that we used in 3u math was cos squared plus sine squared equals 1. Okay, so that was a trig identity that we knew was true, and so we were allowed to use that to do our proofs. If I isolate for cos squared and move the sine squared to the other side, I get 1 minus sine squared. Or I could isolate for sine squared and move the cos squared to the other side. So my trig identities actually gives me 3, right? So I've got the basic cos squared plus sine squared equals 1, and then I can sort of rearrange for cos squared or sine squared as I need it. So notice that these are squared. So you can only use them with sine squared or cos squared. So that means I can't replace the sine, but I can replace the cos squared. So make sure you put it in brackets, especially because we're subtracting. So cos squared equals 1 minus sine squared. All right, so I'm replacing this cos squared with 1 minus sine squared. And then I'm going to just apply that negative or subtraction to the bracket just to remove the bracket. Okay, so I get 1 minus 1 plus sine squared. 1 minus 1 is obviously 0. So I'm going to move everything to the right side. So sine squared is already over there. 1 minus 1 is 0. And then I'll move the 2 sine over. So now I've gone from an equation with 2 variables or 2 unknowns, and now I just have sine. So now I can just do it as I did the other questions. I'm going to common factor out a sine, which gives me that. So I have 1 root at sine theta equals 0. And I have another root at sine theta equals 2. Well, I know sine theta equals 2 is an invalid solution because I know sine theta cannot be greater than 1. So that is an invalid solution. So I'm just solving when sine theta equals 0. So I'll draw my curve. It equals 0 at 0, pi, and 2 pi. And so that is my solution set. Okay. So one root is invalid, the other one I'm going to refer to the graph because it has a value of 0. Okay, let's do one more. So this one has a cos and a sine again. This time it's the sine that's squared. So I'm going to replace this sine squared with 1 minus cosine squared. And then we'll do the same thing. I'm going to remove the brackets. And then we'll collect to, I'm going to collect them to the right. So I'll bring the minus 2 over. 1 minus 1 is 0. And then I'll just factor. So I see a common cosine. Set my factors equal to 0. So I have 2 factors, or 2 roots. This one is invalid because it's greater than 1, so we don't have to worry about that one. And then where does cosine theta equal 0? It equals 0 here and here, which is at pi over 2 and 3 pi over 2. So that is my solution set. Pi over 2 and 3 pi over 2. Okay, so you will have solving equations where you might just have a single ratio and you're going to use your cast rule or your special triangles or your graph or, if necessary, the calculator to find the related angle. You're going to have some that will be required to isolate for the sine or cosine, and you'll have some that perhaps are quadratic trig equations that you're going to have to factor. Okay, so just keep in mind that time where it's invalid. If it's greater than 1 or less than -1, it's an invalid, and you need to indicate that. The last thing that we have to do are double roots.